We are moving on to 6.4 today. In our last assignment, we solved systems of equations by graphing. So you either drew a graph and then found where it intersected, or you used a graph that was given you to find the intersection, or you used a graphing calculator to find the intersection. Today we're going to find those intersections through algebra. Excuse me. So, there are a couple different ways to do this. The first way is referred to as substitution. Okay, so I have the equation for two lines, and I want to know where do those two lines intersect. Now I could graph it and find the intersection, but there's a really valuable algebraic tool that you guys need to learn called substitution. So if you look here, we have y is equal to 6x plus 12, and y is equal to x plus 47. So that is the same variable in two different equations, which means this top equation has to be equal to the bottom equation. So what we do, I take one of the y equals and I replace y with x plus 47. So on the left side I now have x plus 47 equal to 6x plus 12. And it's called substitution because I'm just substituting y for something else. So I'm putting this in here. And now I just have an equation with a variable and constants. Subtract x, subtract 12. 35 is equal to 5x. Divide by 5, and I get x equals 7. What does that tell me? What does that mean? So that is the x-coordinate of the intersection. So these two graphs, one looks like this, and one looks like that. I know at x equals 7, that's where the intersection is. It's 7 comma something. Does that make sense? So I need to also figure out what is the y value of the intersection. Right, I'm going to take this and I'm going to substitute again, and I plug that 7. Does it matter which x I plug it into? No, they'll both work. So if I put that 7 right here, I get y equals 7 plus 47, which is 54. So I now know my intersection occurs at 7 comma 54. And that's how substitution works. All right, let's look at number 2. Okay. Now it doesn't really matter which variable you substitute, although sometimes one variable is easier than the other. So in this case, I have one equation that says x is equal to 2y minus 1. And since that x is already by itself, that will be the easiest substitution to perform. So I'm going to take this 2y minus 1, and I'm going to plug it in for the x in the other equation. So that equation is 4 times x plus 3y equals 29. And where the x used to be, I'm going to plug in 2y minus 1. And I have essentially gotten rid of all the x's so I can solve for y. Now we do a little bit of algebra. 8y minus 4 plus 3y equals 29. 8y plus 3y is 11y. Add 4 to the other side, and I divide by 11. Y equals 3. Okay, now what? Now I need to plug in 3, but one of the equations is easier than the other. Which equation do I want to use? The bottom one. I could plug 3 in here, But then I have to do a lot of work to get x by itself. If I plug the 3 into this one, it's not going to take very much work to figure out what x is. So x is 2 times 3 minus 1. 2 times 3 is 6. 6 minus 1 is 5. So my answer is x equals 5, y equals 3. Do you guys want to see any more of those? You want to see another one? Okay, we'll do one more. One more of this type. Okay, in this case, I'm going to take this 7y and plug it in there. So 7y equals, or sorry, 7x equals 2x plus 20. Subtract 2x. 5x equals 20. Divide by 5. X equals 4. So I know my answer is 4 comma something. I need to plug that 4 back in to figure out what the y value is going to be. And the top equation looks easier to me. So I'm going to plug the 4 in there. 7 times 4 is 28. That intersection occurs at 4 comma 28. And then basically the same thing for number 4, except I'm going to plug this in there and then solve. Okay? But every once in a while, something really weird happens. Except it's not going to happen today. Nope. Okay. We'll cover the weird answers in a little bit because there's no way it's going to happen today because it's not an option in the answers. So anyway, we'll get to the strange equations probably next time. Okay, get to work.